Hello, everyone. Welcome to my little session today. I want to talk about the difference between air and vapor because A, I think it's a really interesting topic, and B, I think there might still be a little bit of confusion out there. So let me share a little presentation with you. Okay, so let's talk about the difference between air and vapor. So to understand the difference between air and vapor, first we need to understand that there are priorities for moisture management. I want to introduce that to you. So there's three different types of moisture we have in our building. So one is from our diffusion, so where water molecules diffuse through our building materials. Then there's air leakage, where air transports moisture through gaps and cracks in our building envelope. And then there's liquid water that comes through any openings that we haven't properly sealed in our building envelope. So liquid water obviously is the most important one, and the first one we want to get under control. So first we want to have our roof properly fixed, our windows, so that no liquid water can come in. Before we haven't done that, we don't even have to look at air tightness yet. So look after that first. Then after we've got that under control, we want to look after our air leakage. So we want to make our building airtight so that we're not having any air transporting water through our building envelope. And then the last one is, with an importance of 1, our diffusion, that we should look after as well, but we can't start doing that before we haven't got our airtightness in check. So just remember that these are the priorities for your moisture management. Now I want to show you why it is so important to do that in this order with this little example here. So we have an airtight construction. Okay, so this is an example of an airtight construction where we still get 0.5 grams per square meter per day of water into the structure by diffusion. Yeah, so that just happens where water molecules diffuse through the building material into our buildup. That's what happens. But compare that to when we have an air leak. So if we have a 1 millimeter gap in this buildup, so this is a 1 by 1 meter, a 1 millimeter gap, Fuge is German for gap, we would now have 800 grams per square meter per day of water because of that air leakage, because air is taking a moisture with it through our building buildup, and we would now have 800 grams per square meter per day in our buildup. And that's a massive amount, yeah? So we had a lot of moisture in our buildup, in our thermal insulation. And because of that, our heat transfer would also be 4.8 times higher, because now our performance of our thermal insulation is compromised, yeah? If our thermal insulation is moist or wet, it can't perform properly anymore. So this is the reason why we need to look after our air tightness first, and then after our vapor control. I also want to explain to you that air and vapor transport isn't the same. Yeah. So air transport finds its way, and air moves through gaps and cracks. So it needs a physical hole where air can move through. And that air transport depends strongly on our atmospheric pressure, the wind speed, or a height difference. Yeah. So that air moves. With our vapor transport, it's a little bit different. Vapor moves in a random motion. So those water molecules in the air move in a random motion, and they can move through material. And now our vapor transport depends strongly on a temperature difference, the absolute humidity, and a partial pressure in our air. So a partial pressure is the pressure that arises from individual gases in a mixture of gases. So we need to look at that as well. So I want to explain a little bit deeper what vapor diffusion is, because that's what we are talking about now. So vapor diffusion is the net movement of vapor from a region of a higher concentration to a region of a lower concentration. And that happens by the random motion of the molecules. So if you were to put a drop of ink into water, that would then move so long until everything is in an equal concentration. Yeah, so that's what this does. It wants to come to an equal concentration. And vapor can move through solid materials if they are not vapor impermeable. So permeation is a form of diffusion. So we use that word interchangeably sometimes. We sometimes say permeation, sometimes diffusion. And if vapor moves through a material, that material can still be airtight. Yeah. So this is probably something that is important to understand. We can have a material like, let's take an example of a sheet of paper. So if you were to put a sheet of paper in front of your face and blow against it, the air wouldn't go through. So paper is airtight. But if you breathe against that piece of paper for long enough, then the moisture in your breath would go through that paper. So it would make that paper wet, and that moisture would go through, and that is happening by diffusion. So paper is airtight, but vapor open. Yeah, so some materials have that characteristic, and that's what we also need to keep in mind. So with that in mind, we want to have a little bit of a look at our airtightness system and vapor control system. So traditionally and practically, those two systems, the airtightness and the vapor control systems, are often achieved with the same product. So one product can achieve both of those. They can be airtight and have a vapor control function. So air leakage needs a physical hole, but it can find the way of the least resistance. So for airtightness, we need to tape all our junctions, all our connections. We need to tape our membranes, and we need a structural integrity. For our vapor control, because vapor moves through materials and moves in a random motion, overlapping would be fine. So if you had membranes and overlap them for vapor control, it would be fine, but we need to tape it anyway for our airtight. Now you may ask yourself about breathability of materials, and I think that this one will explain to you a little bit when you're talking about breathable, because vapor diffusion is also commonly known as something being breathable. Yeah, and I think the better way to look at that is that it's actually a vapor diffusion that's happening. So we're looking here at this typical Gore-Tex material. So in this case, it's waterproof and airtight, but it lets the vapor come through. So your typical jacket would keep the water out and the air out, but your body moisture, your sweat, would still be able to permeate out of that jacket. So that's what is called breathable, but really means the vapor can diffuse through. And that's what we're looking for our building materials as well. So we're meaning something is airtight, but vapor open. And that sometimes we call that breathable. Now we've learned a little bit about the difference between air and vapor. Now we're asking ourselves, where do we want our position of our airtightness and vapor tightness system? That's important to know for our building. And for that, we need to know that the risk, so the risk of moisture and humidity always comes from our hot side. That's because hot air can hold more moisture. Yeah, that's what happens. And when hot air cools down, the relative humidity of the air rises. Yeah, and if we are achieving at one point 100% relative humidity, that's the dew point, then condensation can occur. Yeah, and that's what we want to avoid in our structure. And that's why we need to stop the air and the vapor from the side where the risk comes from, so from the hot side. So we want to stop our air and our vapor. So we want to put our vapor tightness and air tightness onto the warm side of our thermal envelope. Good, because vapor moves from hot to cold. So that means that the material with the highest vapor resistance needs to be on the warm side, like I just said. And in an ideal world, the vapor resistance would drop with temperature so that we have the highest vapor resistance on the inside. Then that little bit of vapor that still comes through can dry out towards the outside. And then we are creating a safe structure. So we want to stop the vapor, stop the air. And with that, we also want to stop the heat going through our thermal envelope. Good. Thank you very much for listening to me. I hope this made a little bit clearer what the difference between vapor and air is. I hope that resonated with you. If you want to learn more about this topic or any other passive house related topics, please jump onto one of our courses. We've got free courses, small courses, short courses, and of course our certified passive house courses that you can jump on. And I would really look forward to see you in one of those.